And as soon as the tickets were released, the website went haywire and the application had crashed. People weren't able to log in. So check real-time queue size. Once we check the real-time queue size, if it is full, then hi everyone. So today we will be working on a queue mechanism for users in an application. So I'll just tell you the backstory of how did of what is the inspiration of this video. So there was an incident that had recently occurred. Many of you might have known about this. So there's a ticket booking website called Book My Show, and they had released tickets for the Coldplay concert in India. And as soon as the tickets were released, the website went haywire and the application had crashed. People weren't able to log into their application. They weren't able to see any data on the application. The application was just loading and never, it never responded anything to the user. So that is something that had happened. And the problem here was that what I feel the problem here was that the front end is readily available because it is over the CDNs. It is deployed on the CDNs. So the CDNs are content delivery network. So whenever you request a website, it hits onto the front end, and the front end servers, that is the content delivery networks, will be giving out all the static content that the website contains, and that will be readily available. But to fill that static content, there has to be some dynamic content like the user information or the current status of tickets, like what seats have been reserved, what seats have been already reserved, or which are available, and all of those things. So these are some things that are dynamic and has to be available from the backend server. But in the case of Book My Show, the backend servers weren't able to respond because they were flooded with traffic from all over the country. So in this case, what they did was they implemented a queuing mechanism. So in this queuing mechanism, there were only a certain set of users that were given access to the original website, and from that they would be able to access the backend servers, and the rest of the users were put into a queue. And many of you might have seen that there was a screen that used to pop up. There, yeah, people were redirected to some other web page, and on that web page they were shown of which number in the queue they are currently standing. So this is what they implemented, and there was also a time limit on the people who were allowed to enter the original website. There was a time limit of some 4 or 5 minutes. I don't remember exactly because I wasn't involved in that as much. So, but they were given some time limit, and once that time limit gets exhausted, you will be thrown out of the queue, and the people who are already in the queue will be pushed into the original website. So this is how they did so as to protect their backend servers, because you don't want your backend servers to be flooded with so much of traffic that you are unable to access your database, you are unable to do anything with all the other services that you have in the backend. So that is why what is more important is to protect our backend servers and limit the requests on our backend servers. So our aim is basically to limit requests on our backend servers on a certain period of time. So let's see how we can do this. Let's find an approach to think through it, and let's not. There might be some high level things that have been going on in the real scenario because it's a very huge scale on which they work. We will not be going into that. We will be just thinking through an approach and finding a way to solve this problem on a very low level, on a very, a physical kind of level, but not get into what kind of services they might have used and what they would have done with those services, how they would have cached these things. The queue status can be cached basically. So there are many things that can actually be implemented, but we'll be thinking through the very basic approach that can be implemented in this case. So first of all, we have a front end and we have a back end. So this is our backend server. Now, the thing with our backend server is that we need to implement a queue mechanism, and we have a front end here as well. So the thing with front end is that it is deployed on a CDN, and the static data will be available to the users very readily. So first of all, we need to decide a limit of how many users can enter the original website. Uh, at a time. So let's say we will not be working on a very large scale. So just for time being, we will consider the limit as 4, or let's say the limit as 3. So at a time, there will only be 3 users that can enter the website. Right. So let's say we have three users that are coming onto the website. So these three users will be normally coming onto the website. They won't face any problem. The things will go normally for them. They will return to the front end. From the front end, there will be some backend APIs that will fetch user data or any other data that is required, and simply everything will be working out. So these are the three users who have landed onto the website, and they are working with the website now. But as soon as the fourth user comes, we need to push that user into the queue and redirect the user to some other web page where the user will be able to see his queue number in live. Uh, in live mode. I want the user to see the queue number in real time, at least for some users. For that also we'll be having limit. Okay, so uh, what we'll be doing here is that we will maintain two queues. One queue will be for the users that are way ahead in the queue and are just going to enter the application. So let's say we'll keep a let's say limit of three. Let's say so we have the actual limit of three. Along with that, we will also limit the, let's say, real time limit would also be three, and and then after that we will be having a queue, endless queue, let's say endless queue. So these are the three things that we have to take care of. Real time, let's call it real-time queue. So what is this real-time queue? So the real-time queue will be something where users will be given real-time information on what number they stand at. For the endless queue, we won't have any real-time information. Uh, for users in the endless queue, they will get information on the basis of polling. But for the users in real-time queue, they will get information on the basis of, they'll be connected to the server using WebSocket. So we'll have to uh, we'll have to create these limits when in a real scenario they might have created these limits, or even if we want to create something of this sort, then we'll have to create these limits considering that there will be enough WebSocket connections for real-time queue to these users, and also there will be also the other users who are on the website will be able to access the backend server. We need to keep in mind both of these things, that we need to have WebSocket connection as well as people interacting with the backend, and a combined and in that, considering these two things, we will have to keep the limit. Along with that, we also have to take care of the fact that there will be some users who will be polling, that is, who will be sending requests within a certain period of time, so as to get latest status of what their queue number is, right? So this is what we will be doing. So in the backend, we will have two queues. So one is the, okay, so in the endless queue, we don't have any limit. We can input unlimited users. Uh, People can just come, or all users will be basically coming into this queue. And for the real-time queue, we have a limit of three. Limit of three. Okay, so now these three users are already interacting with the backend. So we will also keep track of number of people in the people who are interacting with the backend. So let's say the people is three. The value of people is three. So currently let's say there are three people who are interacting with the backend and are currently interacting with the application. So you don't have any scope of including anyone else. Now the next user will be coming in, will be sent to the real-time queue. So for that, what we will do is whenever the fourth user comes in, whenever the fourth user comes in, this is the fourth user. The user comes in. As soon as the user hits onto the backend, we will have something, we will need to implement something that will first keep a check of whether the amount of people who are currently on the website is enough or not, right? So in that case, we will have to create a middleware. In this middleware, uh, there will be some things that will be taken care of. So first of all, in this middleware, what we will be doing is check. check if the limit is reached. In this case, yes, it is reached. If not, if not, go ahead with the go ahead with the operation. If yes, if the limit is reached, then set up a WebSocket connection. So whenever the fourth user comes in, the user will be first, there will be a middleware that will check if the limit is reached. If not, if the real time limit is reached. If not, go ahead with the operations. If yes, set up a WebSocket connection with the user. Now, why are we setting this WebSocket connection up with the user? The reason is that we need to give a real time status of how things are moving in, what is the exact queue number that the user is standing in. All of those things we have to send to the user in real time. That is why we will be implementing this real time queue, and that is why we will be implementing a WebSocket connection with the user. Also, we also have to take care of the fact that whenever the user, let's say this user one finishes his job and he just logs out of the application. Once the user one gets out of the application, we also have to take care of the fact that user four receives that event. Whenever user one uh, logs out, the event has to be fired to user four that yes, user one has logged out. You can now come in, and at that time, from the front end, the user will hit onto the backend. I mean, the front end of user 4 will hit onto the backend. So for that also we need an event that has to be fired onto the user 4. So that can be done using this WebSocket connection. So this is what we will be doing. And all so we have a limit of three. In this limit of three, we will include even more users. User 4, these are the three users who will be establishing a WebSocket connection with the server. Why? Because we need them to have real-time data because they are nearly going to access the application, and we also have to send events to these users so that whenever users from the original application start leaving, we need to redirect them onto the application. So for that, we will put them onto the real-time queue. Now this is done. Now let's say, so as we have discussed, let's say user one gets out, user one leaves the application. Once the user leaves the application, while leaving the application, there will be something that will signal the backend that this user has left. Once this user has left, uh, the people variable will okay, so let's not call it people, let's call it users. The users variable will decrement to 2. Now, once the users variable will decrement to 2, so once user 1 has done his job, the users variable will decrement to 2. Now that the users variable is decremented to 2, okay, so in the middleware, first of all, we also need to check if the users limit is reached. Because if the users limit is not reached, then what is the use of getting into the real-time queue? I mean, obviously the real-time queue limit will not be reached, but if users limit is not reached, then obviously you'll have to proceed with the operations. Check if the users limit is not reached. If not, proceed. Else, do this. Else, check if the real-time limit is reached. If real-time limit is not reached, then set up a connection, then set up a WebSocket connection. If not reached, then set up a WebSocket connection. And if the real-time limit is reached, then push the user to endless queue. So first of all, check if the user's limit is reached. If the user's limit is reached, then we have to check if the real-time limit is reached. If the real-time limit is not reached, then set up a WebSocket connection with that user and send that user to the real-time queue. Else push the user to the endless queue. Okay, so 4, 5, 6 are already there in the application. They are in the real-time queue. So the real-time queue users are three, that is 4, 5, 6. 1, 2, 3 were interacting with the application, and let's not think about the endless queue now. So user one leaves the application, users decreases to two. Once this event occurs, an event will be fired back to user four. Okay. So once user one leaves, let's see how the chronology goes. First of all, the users users will be decremented by one. Once users are decremented by one, an event will be fired to the user at the front of the queue. So how are we going to define this user? Whenever we set up a WebSocket connection, the socket ID will be saved in the queue. So whenever you want to send an event to a certain user, you can use that socket ID simply, and then the event can be sent to that specific user itself. So uh, send connection event, send event to user at the front of the queue, at the front of the queue, right? We have sent an event to the user at the front of the queue. The user at the front of the queue will be redirected to the application. So now the user at the front of the queue will be redirected to the application. This user will now come up to the application. Now user 4 is available in the application, and also pop this user out of the. So this is what we will be doing. Firstly, that is decrement users, send event to the user at the front of the queue. The user at the front of the queue will be redirected to the application and pop this user out of the real-time queue, and increment users. So let's just write users plus plus, and users will be incremented back to 3. Now, we have this real-time queue. In this real-time queue, we have only two people, that is 5 and 6. Let's say we have another user coming up, user number 7. So this is our user number 7 who is coming up. So whenever the user 7 comes, we check if user limit is reached. If not, proceed. Else the real-time limit is reached, which is now not reached actually. The real-time limit is not reached here. So we set up a WebSocket connection with the user number 7. And yeah, along with that, we also forgot one thing over here, that when we pop this user out of the real-time queue, we also have to send to the front ends of this 5 and 6 that you have been moved forward in the queue. That event will also be sent. So this is also something that we'll be doing. Along with that, we also have to indicate this users. So now we have, now if the user 7 comes in after this, then you don't have a problem. Obviously, this middleware checking will be done. But if the user 7 had already been there, let's say, okay, so now we have a user 7. Let's say we have another user 8. So once we have this user, now we see that the real-time queue is full. You cannot have an access to the application. The real-time queue is full, and you just have one option, that is endless queue. So we will jump right onto this line of code. It says that push the user to the endless queue, and the user number 8 will be sent to the endless queues. Okay, so now in this scenario, we have user number 2 who finishes his job and leaves the application. Or let's say the time of user to exhausts and he has to leave the application. So the user 2 leaves the application. Once that happens, users will be decremented to 2. Once users is decremented to 2, send event to the user at the front of the queue, that is to the user number 5. We send an event that you are welcome to the application. And once that event is sent, user 5 will come onto the application. And we will pop this user out of the real-time queue and send event to the users in real-time queue, whoever is left in the real-time queue, to notify that they are pushed forward. So 6 and 7 are pushed one step forward. Along with that, users has been also incremented. But we had 8 in the endless queue already. Now there is some space left in the real-time queue. In the real-time queue, we have one space that is left, and user 8 has to accommodate that place. Now we have to send some event to the user number 8 in some way that we can push the user directly into the real-time queue. But we also don't want to set up a WebSocket. We already have not set up a WebSocket connection with the user yet. Why did we do this? Because we don't want to have so many WebSocket connections that the server cannot handle. So the whole point of implementing all of this approach is that we have to reduce the load on the backend. And if we set up so many WebSocket connections, obviously it will be increasing a lot of load onto the backend. For that mere reason, we had kept this user number 8 in an endless queue, and we didn't include this user in the real-time queue and set up a WebSocket connection with that user. But now is the time that we have to set up a WebSocket connection with the user. But only the backend knows that the real-time queue has some space left in. So that has to be solved using polling. Now, if we are pushing a user to the endless queue, we also need to take care of the fact that what is the user's position in the endless queue, right? So how will we save that? How will we take care of that? For that, we will do one thing, and that is set cookie to the queue number of that user. Right. So if the user 8 comes in when user 5 was also, so user 8 had already come when user 5 was in the real-time queue and user 2 was interacting with the backend. So in this case, let's do that again. User 2 is interacting with the backend. User 5 is in the real-time queue. Now, whenever the user 8 comes in, the actual position of user 8 in the queue is 1, 2, 3, and 4. So fourth user 8 is actually on the fourth position. For that, we also have to send to the user 8 that you are actually on the fourth position. How will we do that? We will do that using a cookie. We will set a cookie for user 8 that you are on the fourth position. Now, user 2 does his job, finishes his job. User 5 comes onto the real-time queue, and now user 8 has to be pushed in. Let's see what has to be done during polling. Okay, so during polling, the user will first send request to the backend. Send request to the backend with cookie, and the cookie consists of the data of what is the queue number of that user. Well, so once we have the queue number, what we will check first is we will check if there if the real-time queue is filled. Okay, so we have the users limit which is set in the backend. So users limit is fixed. Then let's check the size of check real time queue size. Okay, so we are also popping out these users from the front, right? So check real time queue size. Once we check the real time queue size, if it is full, then the next step would be check endless queue size, and if the endless queue size has changed, then send response with updated queue number. How will we calculate this queue number? It will be users, that is, okay, so users are not in the queue. So it will be real time queue limit, that is 3 plus the size of endless queue. So that would actually be the updated queue number for that user. So that would happen in case the real-time queue size is full. Check endless queue size and send responses with updated queue number. If it is same, the response will be same. Otherwise, the response will be different. So nothing to care a lot about that. But if the real-time queue size is not full, let's say the real-time queue size is not full, what should we do in this case? If it is not full, we need to check for this current user, we will uh, check the updated queue number. So we have a user 9 and user 10. For user 9, we will have to find the position of user 9 in this queue, and once we find the position of user 9, we'll have to then see how many people are ahead of user 9, right? We need to find the index of user 9, and then we'll have to check how many people are ahead of user 9. Basically, we'll have to find the index of user 9. Whatever will be the index of user 9, those many people will be ahead of user 9, right? So check endless queue size. Check endless queue size. No, that's not check endless queue size. Check index. Check index of the user in endless queue. check the index of user in endless queue, and then send response with updated queue number. How will we calculate this response? Real time limit plus index. Okay, so now let's go ahead. If not full, then check the updated queue number. How will we check the updated queue number? That would be real time limit plus index. Once we check the updated queue number, if the updated queue number is equal to uh, limit plus one. I mean the real time limit plus one, which means that the real time queue is not full. Along with that, there's a real time limit. The queue number of the user who is polling is real time limit plus one. In that case, pop this user out and send to real time queue, and then establish a WebSocket connection with the user. Right. And yeah, that would be it. So while polling, we will be taking care of these things. User 8 will now come to the real-time queue, and we have user 10 and 9 who are already in the. So yeah, so this is how basically we will be implementing this. So this is completely from scratch and at a very low level. There might be some very nice services that would allow us to do this. So to get to know the queue number at every instance, we need to have a connection directly with the backend server. But in real time case, in real world scenario, there might be some services like Redis or any cache management services that will store this queue size and all of these parameters will be taken care of these cache management services, and they will provide it readily to the users, and that would obviously reduce some more load on the backend. But this is something by which we are trying to manage a bit of load